This lesson is on solving linear equations. Now, just a reminder, linear equations are equations that have one variable and the exponent of the variable is a 1. Here are some examples. Simple examples, they've got parentheses, but they've got one variable only, and the exponent is a 1. Now, I'm going to be solving linear equations. These are the 6 steps for solving linear equations. We get rid of fractions, if we have any, by multiplying by the LCD. We multiply every term by the LCD. Once we get rid of fractions, we get rid of all parentheses by doing the distributive property. If there's more than 2 terms on the left side, we combine like terms. Make sure you hear that. If there's more than 2 on the left. Same thing with the right. If there's more than 2 terms, we have to combine like terms. Now, step 5 is where I start the solving process. You can do either one first. What I like to do first is move the constant to one side of the equal sign and the variable to the other side. Some people like to do it the opposite. Some people like to move the variable first and the constant over. That doesn't matter. I just move the constant to the right and the variable to the left every time. And once we simplify that, we divide by the number in front of the variable. I'm going to work a few examples to make sure you see the process. Alright, I'll start with this one. Notice I've got 2 variables, one on the left, one on the right, and 2 constants, one on the left and one on the right. I'm going to move the constant first by subtracting from both sides. I'll get 3x equals, now for subtracting, signs are different. Plus 8. Then I've got to move the 2x over with the 3x, so we subtract 2x from both sides. And we're left with a single x equals positive 8. If you wanted to check yourself, you could do this. You could put the 8 where the x is on the left side. Put the 8 where the x is on the right side and add them together and see if they equal. You don't have to check it, but if you might want to just to make sure. Alright, the second example has a parentheses. Now I want you to notice there's a negative in front of that parentheses. When there's a negative in front of the parentheses, we distribute a negative, which means we're multiplying by a -1 everything in the parentheses. So that positive 6 becomes negative 6x, that negative 5 becomes positive 5. Now this is an example, let me highlight this. This is an example of where I've got more than 2 terms on the left side. Notice there's an 11x and a 6x. We can combine those together, so we subtract 11x minus 6x is 5x. And we've got a plus 5 and we've got a 40 on the right. Now we can actually start the solving process. I'm going to move the 5 over by subtracting it from both sides. I'm left with 5x equals 35. Then we divide by 5, so x turns out to be positive 7. Alright, we'll highlight that. Positive 7 is the answer. Hey, it's the answer on this one. Number 3, I've got parentheses on the left and the right side. What we have to do is the distributive property. So on the left we're going to get 3x minus 6 plus 7. On the right we'll get 2x plus 10. Now Notice here there's more than 2 terms, so we have to simplify that. We got a -6 and a +7. When we add those together, we'll get a +1. 2x plus 10 on this side. Now, I'm going to move the constant over to the right first. And we'll get +9. Then I'm going to subtract the 2x from both sides. X will be +9. You can move the x to the left first and then the number to the right. It doesn't matter. You should get x equals 9 regardless. Number 4 has a negative in front of the parentheses, which means we're distributing a negative sign. So be careful with that negative. So this will give me 2 minus 7x minus 5. On the right, I still got 13 minus 3x. Notice again, on the left side, there's more than 2 terms, so we can combine the 2 constants. Of course, I've got a -7x. Make sure that negative follows make sure that negative follows our 7x. The 2 and the -5 gives me -3. And we've got 13 minus 3x on this side. Now, I'm going to move the constant over, so I'm going to add 3 to both sides. I've still got -7x on the left. I've now got I've now got 16 minus 3x on the right. I can move the 3 over by adding 3 to both sides. Remember, when you're doing equations, you do the opposite. Since there's a minus here, I have to add to both sides. Combine that, we'll get -4 equals +16. Last thing we do is divide by the constant in front. So we get x to be -4. And again, if you wanted to check it, you could go plug it back in and see that you get -4. Or that you get the same thing on the left and right, sorry. You plug in the -4 and see if the left side equals the right side. Alright, here's another one with parentheses. Now, I've got 2 parentheses, one, then they're both on the right side. That doesn't matter. So we're bringing down the 16. I distribute the 3 through the parentheses. And again, notice there's a minus sign here. So we're going to distribute that negative, and we're going to get -x plus 7. Now, on the right, there's more than 2 terms. So we combine the like terms. There's a 3x minus an x. That's a 2x. There's a -3 and a +7. That gives me a +4. Now, in a situation like this where the x is on the right side, you can move the constant to the left. This is okay. Normally my x is on the left, I move the constant to the right. In this case, my x is on the right, so I'm going to move the constant to the left. And we'll get 12 equals 2x. We divide by 2, so x turns out to be 6. Now, you could also do this. You could take, let me draw a little line over here. You could take, right here, at this step, what you could do is you could reverse it and put the 2x plus 4 on the left and the 16 on the right. Nothing changes. The signs don't change or anything. It just flips the equation over. And you'll still get 6, but that's another option. Some people like to do that and then make it to where the x is on the left side. Certainly doesn't matter to me. Now, my next few examples are going to be fractions. Now, the deal with the fractions is finding the common denominator. In this problem, I've got two denominators, which is a 2 and a 3. The common denominator with a 2 and a 3 is a 6. So here's what I like to do. I will put parentheses next to every term, just like this. Even the 2 gets a parentheses. Even though it's not a fraction, I still put parentheses. Hold on. Now, inside the parentheses will go the LCD. Once we figure out the LCD and put it in the parentheses, we're going to simplify this. And the way you simplify it is you take the denominator and you divide it into what's in the parentheses. In this case, I get a 3. You multiply the 3 and the x together because this is multiplication. So we'll get 3x equals. On the right side, we'll take the denominator, divide that into the 6, and we'll get 2. So on the right side, we've got a 2x. This piece, there's no fraction, so you just multiply 6 and 2, and we'll get negative 12. So we're multiplying by the common denominator and dividing out the denominator into what's in the parentheses. Now we can solve it. And subtract 2x from both sides. We're going to get x to be negative 12. Now you've got to watch your signs. Make sure that you're paying attention to your signs. It's easy to make a mistake. I make them. Everybody makes them. Now, number 7. Now this time, I've got 3 different fractions. 3 different denominators. So we've got to find the common denominator for all 3 of them. Well, here's a little hint for you. You could find the denominator of these 2 first, and then you could find the denominator of that number and the 6. Let me just tell you what I'm talking about. I know the common denominator between 5 and 2 is 10. Now, I could take the 10 and I could take the 6 and find the common denominator. And the common denominator between 10 and 6 is 30. Now, that's just a way you could do it step by step. Or you could just say, well, I know 5 times 5 and 2 and 6 go into 30, so the answer is 30. Either way, the answer is 30. However you want to find it. Now, I'm going to put my parentheses next to everything. And we're going to put the common denominator inside the parentheses. Now comes the division part. The 5 will go into 30 6 times. I multiply the 6 and the x together. Here, 2 goes into the 30 15 times. Now pay attention to that minus sign. We've got a minus 15. On the right side, I divide 6 into 30, and we'll get 5. So we got 5x on the right. Now in this situation, I'm going to flip the equation over. Since there's just an x term on the right, I'm going to flip it so that just that x term is on the left, and then I'm going to move the other x to the left. Some people like to move the 6x over with the 5x, which is perfectly fine. I just don't happen to like that in this case, but I'm going to flip it over, then subtract 6x from both sides. Now, pay attention to your signs. This is going to give me a negative x equals a negative 15. Now we're supposed to divide by what's in front of the x. Now what's in front of this x is a negative 1. So when I divide both sides by negative 1, we'll get a positive 15. So be careful with the signs. It's easy to make a mistake. Now, number 8 is a little bit different because it's got binomials in the top, and you've got to be careful with this. We're going to work it the exact same way. I'm going to put parentheses next to every term, and I'm going to locate. I'm going to find the common denominator and put it in the parentheses. Well, this time we've got a 6 and an 8 and a 4. They can all divide into 24. 6 goes into 24, 8 goes into 24, 4 goes into 24. So 24 turns out to be the common denominator. Now comes the division. 6 goes into 24 4 times. Now you've got to be careful. What you're left with is a 4 in front of an x plus 3. So that's the distributive property. I'm going to write it like this before I distribute. Here, the 8 goes into 24 3 times. Multiply the 3 and the 3, we'll get a 9. There's a minus sign here. That's going to be important. That's easy to mess up on. Now 4 goes into 24 6 times. So what we have is a minus 6 in front of that binomial. So you have to do the distributive property on these. I like to write it like this so that I can see I've got to do the distributive property. So let's distribute. We get 4x plus 12 equals 9 minus 6x plus 30. Make sure you distribute that negative. Everything's going to change signs in the parentheses. Now, on the right side, I've got more than 2 terms, so we have to combine those together before we start doing anything else. Now, the only thing I can do is combine the 9 and the 30, so we'll get 39 minus 6x. Now we're going to start solving it. I'm going to subtract 12 from both sides. I'm left with a 4x on the left and a 27 minus 6x on the right. Running out of room here. Now let's move the 6x over. Add 6x. We're going to get, whoops, let me erase that. We're going to get 10x equals 27. But this time when we divide by 10, we're left with a fraction, and that's okay. The answer turns out to be 27 over 10. So that's the final answer. You will get fractions sometimes, which is okay. Don't freak out over that. But the deal with the fractions to start with is common denominator. Now, I want to talk about some equations that have strange answers in the sense that it doesn't look like the other problems. Some of our equations will end up having no solutions, or it will have an infinite number of solutions. Now, there's only one way to tell if you've got one of these situations, and that's if the x completely disappears from the problem. I mean, it goes completely away. You don't have an x on the left and you don't have an x on the right. The only thing you're left with is a constant and a constant with an equal sign in between. Now, when this happens, when your x goes completely away, your answer will either be no solution or it will be infinite solutions. So how can you tell the difference? Okay. Read my little definition here. For no solution, if you solve the equation and you get a constant on the left and a different constant on the right, that means there's no solutions. So you get a constant on the left and a constant on the right, and they do not equal. That means there's no solution. Now, the symbol for no solution is this. It's called the empty set or the no solution symbol. Either one you want to call it. It's just an O with a slash through it. Now, it's a slanted slash. I mean, I don't make the rules up. It's a big O with a slanted slash through it. Now, for infinite solutions, if you get a constant on the left and a constant on the right, and they are the same constants, that means you have an infinite number of solutions. And that just means every number works in the equation. It doesn't matter what you choose, it'll work on the left side and the right side. There's different notation for infinite solutions. And when we mean infinite solutions, that means all real numbers, basically is what that means. This is a notation for all real numbers that we will use in inequalities. For equations, this is kind of weird looking. It's a funny looking R. Now, different books write it different ways, but those three are the ways you write all real numbers. I typically use the third one because it's easier for me to draw, but they all mean the same thing. If you see infinity symbols on the left and right, that means all real numbers. If you see one of those types of R's, that means all real numbers. Now I'm going to show you an example of each one so you can see how it looks at the end. Okay, now let's start with this equation. I've got parentheses. So the first thing I'm going to do is on the right side, I'm going to get rid of my parentheses. And we'll get this. Now I'm going to solve it just like normal. I'm going to move the 7x over. I'm going to get 3x on the left. 3x plus 10 on the right. Now here's where some people mess up. I've got to move the 3x over. Now, some people think when you subtract a number from itself, you're left with an x. When you subtract something from itself, you no longer have it. It equals 0. There's no x involved anymore because you subtracted it from itself. So on the left side, we've got a 0. On the right side, we've got a 10. Now, there's a constant on the left and a constant on the right. They are not the same. Not the same. If they are not the same, your answer is the no solution. So the x canceled completely out. You're left with two constants, but they were not the same. Number 10. I've got to do the distributive property on the left. So we get 2x plus 4. I'm going to do this all in one step. Also notice over here, there's more than two terms. So we're going to combine like terms. And we're going to get, whoops, I made a mistake. Got to be careful. That should be an 8. Be careful when you're doing the distributive property. We're going to get 2x on the right plus 8. Now, this can be a little tricky also. When I move the 8 over, I'm left with a 2x. On the right, I'm going to write this in. Just so you can see what happens. I'm left with a 2x plus 0. The 8 and the minus 8 give me 0. I want to have a constant on the right side, even if it's a 0. Now, we're going to subtract 2x from both sides, and guess what we get on the left side? 2x minus 2x is a 0. So this is the situation where they're the same number on the left and right. The same. Since they're the same, your answer is one of those R's. I'll just draw this one. It's more comfortable for me. All real numbers. Just remember there's 3 symbols for all real numbers using the R. They're just strange looking. Every book's different. But the whole thing is, if they're exactly the same, it's all real numbers. That concludes this lesson.